Hi everyone. I'm going to talk about a problem in which you've got a volume of liquid and you're pouring some liquid in, and then some liquid pours out at a certain rate as well. And there's concentrations of salt in the water. And you can see the problem there in front of you. The key to this is firstly a good diagram, and then we're going to talk about rate in and rate out. Now, can you read that? Right. So initially, let's draw a little picture. Picture's worth 1,000 words. Here's our tank. A tank is initially filled with 72 liters of water. And this particular tank has, so there's 72 liters initially with 3 kilograms of salt. The tank is to be flushed with pure water, which is running into the tank at a rate. So it's pure water running into the tank at 3 liters per minute. So that's pure water. So that means there's zero concentration of salt going in. And going out, we've got 5 liters, 3 liters. 5 liters, got to read the problem, 5 liters per minute going out of capacity of liquid. And the concentration, we'll talk about that in a sec. So if you let, some people call this volume, but I call it capacity because capacity is the amount of liters. This is the amount of liquid in liters at time t. Now, as we've talked about this already, so let's get this one out of the way. 3 liters goes in every minute. Five liters goes out every minute. So the net is that 2 liters goes out every minute. So we've got ourselves an equation for the capacity. It starts at 72 liters, and every minute 2 liters leaves the system. We'll call that equation 1. So after t equals 36 minutes, there'll be no liquid left in the container. We'll put a star next to that one. We might refer to that later. So that's the first thing. The second thing, S. S is the amount of salt in kilograms present in the tank at any time. So the number of kilograms of salt, it really helps to write the sentence out, per liter in the tank at time t equals S of t, that's the amount of salt present in the tank in kilograms, so that's kilograms, over the capacity, and that's liters. It also helps to put in the units as I'm doing there to do all these calculations. This is like physics. In physics, you do stuff like that. So we're getting close. We know the concentration at time t of the salt in the water. So we can work out how much salt leaves the system per minute. Therefore, if 5 liters flows out each minute, the amount of salt flowing out each minute in kilograms at time t is, so it's S of t over C of t. We know what C of t is. So that's kilograms. Let's put the units in. Multiplied by 5 liters per minute. That's the amount it flows out. So can you see here that liters cancels? So that gives you 5S over C of t. And we can replace that with 5S over 72 minus 2t. That means we have ourselves an equation. ds dt is equal to the rate in minus the rate out the rate in is 0 and the rate out is S over 72 minus 2t, as we've just calculated there. So that gives us the equation ds dt equals minus S over 72 minus 2t. There's our equation. Now we're going to solve this equation. So this is the next section, solve it. So we've got the SDT. Okay, I'm rewriting it because the page will disappear in a sec. Minus S over 72 minus 2t. And we've got our initial condition on this, S of 0 equals 3, because we know there's 3 kilograms of salt initially in the solution. That's separable, so we go, okay, ds over S equals dt over 72 minus 2t. Integrate both sides. Log S equals there's a minus already in front, so there's going to be I forgot the 5, didn't I? We'll put the 5 in. How about that? Okay, 5 on 2 log 36, because there's that 2 from the 72. You take the 2 out, you get 36 minus t plus c. Now, obviously, t is between 0 and 36. So S, we're going to take this here using log laws and put it up as an index. So we'll get ln S equals ln 36 minus t to the power of 512 plus c. And so finally you'll get S equals e to the c, and then 36 minus t to the 512. Use your initial condition and you could figure out what e to the c is. T is 0, so that's 36 to the 512 implies 3, well, let's just write e to the c equals 3 over 6 to the 5, which is 1 over 2592. And so finally, you'll get S as a function of T equals 1 over 2592, 36 minus T to the power of 5 on 2, and T is obviously between 0 and 36. And we know that at 36, it'll be 0, so we can put that 36 in there. Yeah, and there you have it. I don't really need to put a box around it, I guess, but there it is anyway. And that's it. So that's the problem. Now I can't, I'll just leave it like that. Can you see that? All right. Okay, I hope that was really clear for you guys. Please put any questions in the comments and I'll clarify them if you have any. And thanks for listening. See you next time. Cheers.